Hello everyone, welcome to Irfan CFPS YouTube channel. If this is the first time you are watching my channel, make sure to hit the subscription button and also click the notification icon. After reviewing various Cleanagent system design, I have seen critical errors repeated over and over. So I have decided to start NFPA 2001 video series. This video series will be helpful for engineers who are involved in fire protection industry. In today's session, I am going to cover various basic concepts of Cleanagent systems. So let's get started. So by the end of this video, you will have clear understanding of Cleanagent systems, including their applications, typical system arrangements and their system components, the different types of Cleanagents, how to choose the right Cleanagent, and also we will be covering the important safety concerns, common design approaches and the system configurations. What are Cleanagent systems? Basically, Cleanagent systems are gaseous systems that are used to extinguish fires without leaving residue, and also they are used to limit the damage for the sensitive equipment. They are ideal where water sprinklers could cause damage or the water-based systems could not be used in certain applications. NFPA 2001 requires these agents to be electrically non-conductive for safe use around live equipment. This allows fast recovery and minimal downtime after discharge. They are stored as liquefied gas and the discharge will be like vapor to quickly flood the protected area. Fire is suppressed by lowering the oxygen or interrupting the chemical reaction. This is the extinguishing mechanism of Cleanagent systems. Common applications of Cleanagent systems include data centers, server rooms, electrical switchgear rooms, control rooms, telecommunication facilities, UPS power rooms, hospitals, medical centers, battery rooms, museums, art galleries, libraries, computer rooms and facilities, etc. According to NFPA 2001, these systems are suitable for Class A surface fires, Class B flammable liquid fires and Class C electrical fires. I already discussed definitions of Class A, Class B and Class C in NFPA 10 video series. You can check the playlist. However, these Cleanagent systems are not recommended for deep-seated fires in Class A materials. So let us try to understand the typical system arrangement of Cleanagent system. As you can see on your screen, there is a particular room which might be electrical room, server room or telecommunication room for example, and this room is protected by the Cleanagent system. Please note, when we say Cleanagent system, it means it will have two parts. One is mechanical part, the other is electrical part. In mechanical part, you will have the cylinders, cylinder valves and also the piping network and nozzles, etc. In electrical portion, you will have a releasing panel which is also called as extinguishing panel, smoke or heat detectors, bells, horn strobes and strobes or horns, abort switches, manual pull stations, etc. So for now, please note this is a typical system arrangement for Cleanagent systems. One more thing I would like to highlight you. The sequence of operation for each system can be different. So in our video, I am going to explain the basic concept of the sequence of operation just for your understanding. We are going to deal about this particular topic in detail with the sequence of operation once we are going to have a discussion on various Cleanagent system types in future classes. So for example, now if the fire is detected inside the room by smoke or heat detectors, the signal goes to the releasing panel. This will start the pre-discharge sequence. What does it mean? It means once the signal is detected, the agent will not release from the cylinder. Why? Because as per NFPA 2001, there should be a time delay of 30 seconds before the gas is discharged from the cylinders. And second most important point, the system first triggers the horns, horn strobes or bells or notification devices, in short, to warn the people so that they can evacuate from that particular room within this 30-second delay time period. During this delay, there should be one more operation has to be done, such as HVAC equipments in this particular room shall shut down, and also dampers shall be closed to seal the room so that the gas should not be released. There is a concept of design concentration and all those things we are going to discuss in further classes about that. And for example, if you find a false alarm inside this room, you can press the abort switch to stop the discharge before the countdown ends. After the delay, the panel sends the signal to the solenoid valve of the Cleanagent cylinders. Once the delay is over, the agent will be released through the piping network through the nozzles so that the fire can be suppressed quickly, usually within 10 seconds, I believe, as per NFPA 2001. So there is also a manual releasing station which is connected to the extinguishing panel. I believe you already know about the manual releasing or manual pull station concept. You can check my NFPA 72 video series which is available on my YouTube channel. So if someone needs to activate the agent, or if someone needs to activate the system before the detectors give signal to the panel, we can activate by using manual release station. Let us discuss the system components. First of all, we are going to cover the mechanical portion of the Cleanagent system components. So as you can see on your screen, there is a cylinder which is fixed with the brackets, and the gas will be inside the cylinder. Apart from that, this cylinder is connected to the nozzles through the piping and fittings. We can also use flexible hose to connect it to the piping network from the cylinder, as you can see here on your screen. The most important portion is the topmost portion of the cylinder. You will have here like manual actuator, electrical actuator, cylinder valve, pressure gauge. Also you will find a pressure switch which needs to be installed near the main cylinder or near the container. If you have only one container, this is the system components. If you have multiple containers, then there will be two options, and in this particular slide I am going to cover the first option. If you have multiple cylinders installed in a particular room to protect that particular room. So the first option would be like you will have the cylinders and also a pilot bottle or pilot cylinder. The purpose of this pilot bottle or pilot cylinder is to activate the main cylinders. So in this particular case, there is no main cylinder or slave cylinder. Everything is main cylinder, but in order to activate these cylinders, we need to use the pilot bottle. Pilot bottle will have manual actuator, electrical actuator, and there is a tube which will be connected to the pneumatic actuator of the cylinders, and from the cylinder there will be a flexible hose and a check valve and a manifold, pressure switch, and so on. All this will be connected to the nozzles. So if you have the second option, there will not be any pilot bottle to activate the cylinders. Then how the system will work, I will show you in next slide. So if you look at this particular slide, you can see this will be the second option. If you have multiple containers, in this you will have a main cylinder and the others will be like slave cylinders. How the system will activate? The main cylinder will have the manual actuator and electrical actuator, and there is a pitot tube which will be connected to the slave cylinders. So master cylinder can be manually or electrically operated, and the other slave cylinders will be actuated pneumatically by means of pneumatical actuation by the action of the master container discharging. So pressure switches in this case should be located close to the last slave cylinder. So if you look at the electrical part, this is very simple. You will have a releasing panel, and in order to detect the smoke, we will have smoke or heat detectors. Apart from that, if you want to activate the system manually, you will have the agent release manual releasing pull station. You will have abort switch. Apart from that, you will have a disable switch, or you will have a maintenance switch, and bells, horn strobes, horns or strobes, etc. These covers the main components of the electrical part of clean agent systems. Let us have a look at the various types of clean agents. There are two types. Number one, halocarbon agents and inert gas agents. So FM200 and Novec comes under halocarbon agents. Inergen and various others comes under inert gas agents. If you look at the extinguishing mechanism, basically FM200 and Novec primarily absorbs heat and interrupts the chemical reaction, while inert gas agents absorb heat but they lower the oxygen concentration as well to a particular point where combustion can't continue. And the discharge time period for inert gas agents will be about 60 to 120 seconds, as you can see on your screen. So when choosing the right clean agent, you must consider various factors, and it's important to consider the difference between the halocarbon agents pros and cons, and also inert gas agents pros and cons. If you look at this particular slide, for FM200 and Novec, they require less space in order to accommodate in a particular room, and the operating cost at the initial stage will be very less, and they have lower discharge pressures. But the disadvantage is like refilling is more expensive after the clean agent is discharged from the cylinders. If you look at the inert gas agents, they provide longer retention time inside the room, no fogging during the discharge, better visibility as compared to the halocarbon agents, but higher installation costs due to large cylinders and piping. They are cheaper to refill after the discharge. Please note, mostly halocarbon agents are used in United States and Middle East, and inert gas agents will be used in Europe. So while clean agent systems does not have major safety concerns for people as well as for the electronic equipment, however, there are certain safety concerns which needs to be understood. So for example, if you look at the screen, there are halocarbon agents such as FM200 and Novec, and there is a concept like design concentration which needs to be selected while we design FM200 or Novec system, and also for inert gas systems as well, as per NFPA 2001. However, that concept will be covered in further classes. For now, please note, if we select the design concentration quite high than required, then they may cause health issues during the discharge, and if we consider the concentration less than the requirement, then they may fail to extinguish fires, and they may produce hydrogen fluoride, which is toxic and corrosive. Apart from that, some of the clean agents have high global warming potential, and the discharge side effects will be like they may cause loud noise during release. Obviously, this should happen because of the large pressures in the cylinder, and also brief fogging of the room can reduce visibility. If you look at the safety concerns of the inert gas agents like Inergen, if you have over concentration, they can reduce oxygen levels too much for safe breathing. Since I already explained before, that the one of the mechanism or extinguishing mechanism of the inert gas agent is to lower the oxygen concentration, thereby suppressing the fire. So if we have selected the design concentration less than the requirement, then they may fail to extinguish fires, similar to the halocarbon agents. So regarding the environmental concerns, generally they are more eco-friendly, zero ozone depletion potential, and the discharge side effects may cause loud noise during release because of the higher pressures. Brief fogging of the room can reduce visibility. So now we are going to discuss the typical design approach for the clean agent systems. So if you look at this particular room, you have the cylinders installed, and this will be installed on the floor. Below this floor there is a raised floor, and you have the suspended ceilings as well. So whenever the designer calculate the agent quantity, he need to consider the complete room including the raised floor and the area above this false ceiling below the slab, apart from the room volume itself. So I will explain you in detail in couple of minutes. If you look at this particular screen, designers must calculate the agent quantity based on the room volume, which includes, as I said, the raised floor volume, the room volume, and also the volume above the suspended ceiling. Apart from that, they need to consider the minimum design concentration with some safety factor as per NFPA 2001. So minimum design concentration for each clean agent will be different for different hazards, including class A, class B, and class C fires. So we need to check NFPA 2001 whenever we consider the minimum design concentration for any clean agent. Apart from that, we need to consider specific characteristics of the particular agent, like vapor pressure and density, and also the room temperature matters. Apart from that, the altitude of this particular building is also matters when selecting the clean agent system. So for example, if you look at the screen, I will just try to draw a particular room just to show you how the floor looks like, or a particular room looks like. For example, you have a raised floor. This will be raised floor. Below the floor, which will be around 1 meter or something like that, which will not be more than 3 meters, or it will not be that much higher. So this will be the room volume, and this will be the raised floor volume, and this will be the ceiling. So this will be the slab. So this area is considered as a volume above the suspended ceiling. So whenever we design the clean agent, we need to consider the entire volume of this particular room. I hope you understand this particular concept. In detail, we will discuss in future classes when we discuss about various types of clean agent systems according to NFPA 2001 requirements. So now let us try to understand the system configurations. So if you look at this screen, you have total flooding system, localized or local application systems, and you have rack mounted suppression systems. So I'm going to cover these two topics in this session. If you are interested to learn about rack mounted suppression, let me know in the comment section so that I will cover this topic as well. So if you look at the total flooding system, it means these systems or these clean agent systems fill the entire protected room with the agent. It's best for enclosed spaces like server rooms or telecommunication rooms, etc. So localized applications or local application systems are used when the agent needs to be discharged directly onto a particular equipment or directly onto the fire area without filling the whole room. So this is used where fire hazard is limited to a small zone, something like a machine or an electrical equipment. So I hope you understand today's session. In next classes we are going to cover in detail related to the design part and how to calculate the actual design or actual agent quantity for Cleanagent systems. So if you find my video helpful, make sure to subscribe and click the notification icon to get more updates whenever I post any video. And also you can find various playlists available on my YouTube channel related to firefighting and fire alarm systems, and they are 100% free. Thank you so much. Bye.